Hi folks, and welcome to Section 3, Module 1, Doing Data Right, part of PAC's video course, Power BI for Business Professionals. In this section, we'll be focusing our attention on doing data right. Now, in the world of data models, whether it's for Excel, Analysis Services, or Power BI, data done right means organizing our data using what the data warehouse people refer to as dimensional modeling. A top chef would never rush food preparation before he or she cooks. Similarly, we must take the time in our initial data preparation to ensure that our results are ultimately going to yield a world-class Power BI report. Doing data right. We'll start by taking a look at what is called a reporting table. A reporting table is very useful for human beings. In this particular case, we have columns for 2007, 2008, and 2009. And if we pick a particular product, I can scan from left to right and see the trend in product sales over time. This reporting format that's so very useful for human beings is almost useless for Power BI. And this is because Power BI is designed to perform its mathematical operations, whether they're simple like sum and average or very complex statistical operations. It organizes these operations by columns. There's no real direct way that we can add up a value from this column, a value from that column, and a value from that column. We can do it, but it's extremely inflexible. What we need is what the data warehousing people refer to as a fact table. So I'm going to right-click on the reporting table, choose Delete, go back to the data source, and we'll import a fact table. We'll go to Microsoft's Contoso Retail Data Warehouse Sample Database. There's a fact table called Fact Sales. And after I've selected Fact Sales, we can open up the Power Query Editor. We're going to import the data, of course. And one of the first things we want to do is we want to give the fact table a more user-friendly name. It's not rare in the world of data warehouses to prefix the table name with fact to indicate that it is, in fact, a fact table. But we're going to give it a more user-friendly name. We'll call it reseller sales. That way, no one will confuse the facts in this particular table with the facts in the online sales table. Whenever we import a new fact table, or any table for that matter, we want to take time to make sure that the data types are reasonable. We have a date key, that's a date-time data type. The various costs are currency amounts. The order quantities are integer amounts. Everything seems to be fine. However, we also notice that there are several columns here: ETL load ID, load date, update date. These columns are used by the data warehouse administrators to keep track of their internal administration and update efforts. They have no value for a Power BI report, and it's extremely important for us to get rid of anything we don't need. Every byte of memory is precious for an in-memory database like a Power BI data model. However, I'm not going to do that immediately. For purposes of comparison, I'm going to click Close and Apply. Power BI will import all the rows. It's a tad over 3.4 million rows. We'll come back to that fact in just a moment. Let's edit that fact table by going to Edit Queries, returning to the Power Query Editor, and deleting those columns that we just decided we really didn't need. I'll select all three and simply remove them. Now that they are removed, we'll apply the changes, save again, and now we'll go back to the Power BI Explorer by getting rid of those columns, we saved a grand total of 9 kilobytes of hard drive space, and by implication, 9 kilobytes of RAM. Hardly seems worth it. What happened? We'll go back yet again to the Power Query Editor. The columns we deleted contained a great deal of redundant data. In other words, the same values appeared on many rows. Such columns are very highly amenable to compression. That meant that even before we deleted them, they weren't taking up very much space at all. Now there's another column here. In fact, it's the first column. This is a key value where each row in the fact table is assigned its own unique integer. We do not need this value for our Power BI report because our Power BI report is never going to be looking at individual row values. Our Power BI report is only going to be aggregating row values. So we can delete this column as well, but when we're deleting this column, we're deleting unique values, millions of them. Unique values are not amenable to compression in quite the same way. So once again, we'll close and apply. Once again, we'll save. And once again, we can go look at the File Explorer. And now we see that the total amount of data is 31,453,000, less than half of what it was a moment ago. And we achieved that 50% savings by deleting one column that we didn't need. This is an important fundamental principle of Power BI data models. The columns that take up the most space are the columns that have the greatest number of unique values. So let's go back once again to Power BI. We can look at the reseller sales table, and we can look at the columns in this table. In the next section, we're going to see how we can start using some of these key columns to relate to other tables that we're going to call dimension tables. Obviously, if we have something like product key, we'd much rather see the product name than the product key. So these key values have to be there. However, we don't necessarily want those key values cluttering up the user interface, particularly for marketing people and financial analysts who might not appreciate the details of why those key values have to be there. Columns that we need but do not have to be visible to the user can be set to hidden. So we can do this by just right-clicking, and there's a choice that says Hide in Report View. When you hide a column, that column is functionally there for Power BI to use, and it can also be used by you or other users in DAX expressions. It's still available. It's simply not visible in the user interface. It means less clutter and less confusion. So if we return to the reporting interface and look at the reseller sales table, we only see those important values. We do not see the list of keys that we don't really need to generate our report anyway. So that's the fundamentals of creating a fact table. By itself, a fact table is not particularly useful. To make the fact table useful, we're going to want to associate it with dimension tables. Dimensions are nothing more than the different ways in which we're going to want to look at and aggregate and study our data. And we're going to study those dimensions in the next module.